Welcome back to our third video in our mole-to-mole conversion factor mini-series. In this video, we are going to explore how we can use the mole-to-mole conversion factor in order to convert from a certain amount of one product to a certain amount of another product. So specifically, we're going to be looking at the reaction up here where we have 2 moles of KClO3 reacting to form 2 moles of KCl and 3 moles of oxygen. So in this problem, what we're being asked is to figure out how much of one product, right, in this case O2, is going to be formed given a known quantity of KCl being produced. So specifically, we're told that 0.8157 moles of KCl are formed. Our goal here in this problem is to figure out how much of the other product over here, in this case oxygen, must have been made as well. Right? So you know the reaction's been carried out. We have no idea how much reactant was there at this point, but we know there is sufficient reactant present to form 0.08157 moles of our first product here. So we want to figure out how much of our second product, oxygen, must be present. So the conversion factor we need to form here, following the approach from the last 2 videos, basically is a conversion factor that takes us from moles of KCl, so we're going to have mole KCl in the denominator there, and gets us into the units of moles of oxygen. So we'll put moles of oxygen up top. Now, once again, the numerical values for each one of these molar quantities are obtained from the stoichiometric coefficients in our balanced chemical reaction equation. So the stoichiometric coefficient for oxygen here is 3. The stoichiometric coefficient for potassium chloride is 2. Now that we have that conversion factor, we basically do exactly what we did in the last 2 videos. We're going to start off with our 0.8157 moles of KCl, and we are going to then use our conversion factor, mole KCl over mole and mole oxygen there. We're going to plug in those stoichiometric coefficients. Once again, I'm just pulling them from that balanced chemical reaction equation. And if we carry through the math on this one, you should obtain a value for roughly 1.223 moles of O2 because our moles of KCl have canceled out. Now, word of advice before we start moving on to some more complex problems. Notice how whenever I write down the units associated with a given numerical quantity, I'm not just writing moles, I'm writing moles of what? Right? And this is something that it's going to be very important to stick to. And we can see the importance of that when you write down one of these molar ratios. It's very easy and a very common mistake that students will make is to start moving quick and just pulling off coefficients and just writing 3 moles over 2 moles, right? But then it's much more challenging for you to see what's actually canceling out. Now, of course, when you're doing a relatively simple problem like the ones we've seen so far, it might not pose too big of a problem. But what we're going to see in the next video is, when we're actually working in the lab, we're not going to be dealing with molar quantities. We're going to be dealing oftentimes with mass quantities, so grams. Or we're going to have multiple different amounts of different reactants or products. And so there's going to be a lot of different conversions we're going to have to carry out. So following the procedure of writing down each one of the units with their associated chemical species that they're tied to is going to be very important. So in the next video, we're going to expand on this problem a little bit, and rather than going from a moles to moles conversion, we're going to introduce the concept of mass.